Okay, hello again. My name is Brooke. This is the Chapter 1 test review. And so what I'm going to do for these review for each of the 5 chapters is in the textbook, I'm going to go through and work through some of the problems in the chapter test. Now, this is on page 54 of the textbook. It's just called the chapter test. There's 13 problems. If you haven't already done so, I would strongly recommend that you attempt the problems before you watch this video. So if you haven't done so, maybe you want to go ahead and do that. If not, you can kind of stop and work problems and then kind of go back and forth. So you can watch this as many times as you want and just do whatever it is that is going to help you do best on the Chapter 1 test. For much of this, I'm going to be working the problems on the overhead camera over there, and I'll try and talk loudly enough so that you can hear me as I'm doing the problems. Hopefully that's the case. You may have to turn up the sound a little bit, but hopefully you can hear me okay. Alright, so the first problem. We want to find the distance between those 2 points, and we just want to use the distance formula. And so we'll take the square root we'll take the difference in the x's first. So we'll take 4 minus negative 2. And then we'll take the difference in the y's. So we'll take 5 minus negative 3. 4 minus negative 2 is 4 plus 2, which is 6. 6 squared is 36. 5 minus negative 3 is 5 plus 3, or 8. And 8 squared is 64. If we take 36 plus 64, we get 100. And obviously the square root of 100 is 10. So the distance between those 2 points is 10 units. And again, hopefully you can see that okay. For part B, we want to find the midpoint of the segment connecting those 2 points. And recall, to find the midpoint, what we're going to do is have an ordered pair, and the x's, the x coordinate of the midpoint is just the average of the x's. And to find the average of the x's, you take the x's and average them. So take negative 2 plus 4 divided by 2. The same thing for the y's. Negative 3 plus 5 divided by 2. And when we do that, we take 4 minus 2 is 2. 2 divided by 2 is 1. And 5 minus 3 is 2. 2 divided by 2 is 1. So the midpoint of the segment connecting those 2 points is 1, 1. Next problem, we want to plot this, and I think they want us to plot this by creating some sort of an XY table. We realize that this is a line, and so we could probably plot it a little bit easier if we did that. But let's go ahead and do what I think the book envisioned us doing here. So let's put in 0, 1, and 2 for x. If you put in 0 for x, you get negative 7y is equal to 21. Maybe what it would be easier to do is just solve this thing for y. So you get negative 7y equals negative 2x plus 21, and go ahead and divide by negative 7. So you get 2/7 x minus 21 divided by 7 is 3, so minus 3. And so that might actually shape some of the points we want to plug in. If we plug in 0, we get negative 3, obviously. 1 and 2, although you could plug those in, things might become a little bit more difficult. So let's plug in 7 instead of 1. If you plug in 7, 2/7 times 7 is just 2. 2 minus 3 is negative 1. And then maybe another point that would be easy to put in would be 14. Multiples of 7 are going to be easy because we're going to be dividing by 7. So if you put in 14, 14 divided by 7 is 2. 2 times 2 is 4. 4 minus 3 is positive 1. And so if we plot those points, 0, negative 3 is here. Here's 7. 7, negative 1 is here. And there's 14 and 1. And so these points lie in a line that looks something like this. You can see that okay. Well, this is the x-axis and this is the y-axis. And the next one, we want to plot y is equal to x squared minus 5. Again, if we just want to create an xy table, we'll talk about how to graph parabolas at a later time, but if we just want to create an xy table, maybe put in -1, 0, +1, those might be some okay numbers to put in. If you put in 0, you get -5 obviously. If you put in 1, 1 squared is 1, 1 minus 5 is -4, and the same thing for -1, because -1 squared is also 1. And so 0, -5 is here. 1, -4. And so hopefully you kind of realize that this is going to be a parabola and it's going to look something like this. You can put in a couple more points if you wanted to, but that's probably good enough for this. On this one, we want to use a TI to approximate the solutions. For the first one, what we want to do is probably just plug that point in, or plug that equation in, I'm sorry. Try to make this as large as I can. So go to y equals, and you put in 2x cubed minus x squared minus 2x plus 1. And for the window, we just go zoom and standard. It's probably going to work. Zoom standard 6. And so the solutions are just going to be where the graph of this thing is equal to 0, or the x-intercepts. And so remember, what we can do is go second and trace, which is the calculate button. Then go 0. Go to the left, to the right of it. And so the first one is -1. That's one of the x-intercepts. Then we have to repeat this for each of those. Looks like there's 3. Looks like the second one is 0.5. And the third one I'm just going to the left of it, to the right of it, and then just choosing to guess. It looks like the third one is +1. So the solutions I could write this way. The solution set would be -1, +0.5, and +1. The next one, we've got a new equation here. And so what we want to do is type that one in as well. You can clear the old one out. X to the 4th minus 5x squared minus 8. And do zoom standard, zoom 6. It's an easy way to graph these. It looks like there's 2 places where this equation is equal to 0. And so what we could do is same thing we did last time. So we want to go to the left of it on the curve, the left of the crossing, the right of it, and then a guess. So it looks like -2.5049. I think the book wants us to round to two places, so we would say negative 2.50. And then to find the other one, we repeat this process. So go just to the left of it, of that crossing, then go just to the right of it, and then a guess. And so by symmetry we could have also gotten this, but it's positive 2.50 to two places. So I would write the solution set as this, negative 2.50 to positive 2.50. And then the third one, they give us negative x cubed plus 7x minus 2 is equal to x squared plus 3x minus 3. We could move everything over to the left-hand side and repeat the same process that we've just done, but what I'm going to do is show you the other method the book has for this one. And that is in equation 1, put in negative, and by the way, you have to push the negative sign, not minus. Negative x cubed plus 7x minus 2. And then in y2, put in x squared plus 3x minus 3. And do zoom 6. And the solution here is going to be the spots at which these graphs cross. And so it looks like there are 1, 2, 3 places where these graphs cross. And so what you would do is, again, go into that calculate menu and find intersect, and let it know which one the first curve is. So this is our first curve, this is our second curve, and we have to put this little dot close to which one we think it is. So we think it's, the approximate intersection here is negative 2.46 to two places, so that would be one of our solutions, and we just repeat that for each of these. So negative 2.46, then we do the same thing over there, and that looks like negative 0.24, and we'll do it one last time. .699, so that's 1.70. So that would be our solution set for number 6. And again, I think my math lab wants us to round to two places. Number 7, they give us 2 points and they want us to find the slope first, so we can do that. We take y2 minus y1, so take negative 1 minus 3 over x2 minus x1, so that's 5 minus negative 1. Be careful with your negatives. So that's negative 4 over 5 minus negative 1 is 5 plus 1 or 6, so that reduces down to negative 2/3. So the slope is negative 2/3. Interpret the slope as x increases by 3, y goes down by 2 units. So just remember, slope is rise over run, and so the negative 2/3 means as x increases by 3, y goes down by 2. Number 8, sketch the graph of y squared is equal to x. Again, we could just kind of plug points here, or look at this in a few ways. Maybe what we would want to do is some points. And in this one, since it's the y squared is equal to x, maybe what you'd want to do is kind of go backwards. Instead of plugging in points for x, maybe you'd want to plug in some points for y. So let's see. Let's plug in -1, 0, and 1, maybe, for y. If you put in -1 for y, -1 squared is +1, so that would be x. If you put in 0, 0 squared is 0. If you put in +1, you square it, you get +1. And so what you kind of see here, this is going to be a parabola, except since we've switched x and y, it's going to be a parabola on its side. So sketch the graph. 1, -1 is here. 1, +1 is here. 0, 0. And so what this is a parabola on its side. Number 9. We want to give the intercepts and then test for symmetry. And so let's start with the x-intercept or intercepts. X-intercepts, we put in 0 for y and solve for x. So if you put in 0 for y, you get x squared is equal to 9, and x is equal to plus, after we square root, we get plus or minus 3. So both positive and -3 will work in that equation. And so the intercepts are positive and -3, or -3, 0, and +3, 0. Y-intercept, or intercepts, I guess. We put in 0 for x and solve for y, and that just gives us y is equal to 9. So 0, 9 is our y-intercept. Test for symmetry. Recall that when we test for symmetry of the x-axis, we replace y by -y. So we replace y by -y, and then we check to see if that is going to be the same. That's obviously not the same. So since this is not the same as the original, we do not have symmetry with respect to the x-axis. For the y-axis, we replace x with -x. And because we have a -x squared, that actually ends up being the same as x squared plus y is equal to 9. That is the same. So since this is the same as the original equation, we do have symmetry with respect to the y-axis. And symmetry with respect to the origin is, find some room here. Symmetry with respect to the origin, we replace both. And so we get x squared minus y is equal to 9, and that's not the same. So in this one, we do have symmetry with respect to the y-axis. Number 10, write the equation of the line that has slope -2 goes through 3, -4. And what we're going to do is use the point slope form of a line. That's the easiest way to write that. So it's y2 minus y1 equals m. Y minus y1 equals m times x minus x1. You can write it the other way, but this is, I think, typically what people do. So we know the slope, and we've got a point, so we plug those in. So it's y minus y1 is -4 equals m, which is -2, times x minus 3. So it's y plus 4 is equal to, after we distribute, -2x plus 6. And we get y is equal to -2x. When we subtract the 4, 6 minus 4 is +2. So y equals -2x plus 2. Just using the point slope equation. the general form of a circle with center 4, -3, and radius +5. Let's go ahead and write the standard form first. It's x minus 4 squared plus y minus -3, so that's y plus 3 squared is equal to 5 squared. And what we want to do is just multiply everything out. X minus 4 squared is x squared minus 8x plus 16 when we use FOIL. And the other one we get y squared plus 6y plus 9 is equal to 25. And for the general form, we just want to move everything up. So we get x squared minus 8x plus y squared plus 6y, and then we'll take 16 plus 9 is 25, and we can cancel the 25s, so it just equals that. Number 12, find the center and radius and graph this circle. So what we want to do is complete the square here. So we'll take x squared plus 4x plus y squared minus 2y. And we'll move the constant of the 4 over to the right-hand side. And remember, when you complete the square, you're adding the b term divided by 2 squared. So here the b term is 4. 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4. And here, I'll take the b term is 2. 2 divided by 2 is 1. 1 squared is 1. So here I added 4, and here I added 1. So I just wanted to go ahead and do the same thing on the right-hand side. Added 5 to the left, so I'll add 5 to the right. Keep it balanced. So it's x plus 2 squared plus y minus 1 squared is equal to 9. And so the center is -2, +1. And the radius is the square root of 9, which is 3. So if we were to graph this thing, here's 2, -1, and a radius of 3. So we go 3 in each. 1, 2, 3. So the circle would look something like that. And number 13, we're using the line 2x plus 3y is equal to 6. What we may want to do is write that in slope-intercept form first. So 3y is equal to -2x plus 6. And then we'll go ahead and divide by 3. So y is equal to -2/3 x plus 2. So the slope of that line is -2/3. If we want to write the slope of the line that's parallel to that, the slope of this line will also be -2/3 because parallel lines will have the same slope. And it contains the point 1, -1. So we can just go ahead and use the point slope form. So y minus y1, so y minus -1 is equal to m, -2/3, times x minus 1. So you get y plus 1 is equal to, when you distribute, you get -2/3 x plus 2/3. And we'll subtract the 1 over. So you get y is equal to -2/3 x plus 2/3 minus 3/3, because 3/3 is the same as 1. And 2/3 minus 3/3 is minus 1/3. And then finally, for part B, find the line that's perpendicular to it. The slope of this line will be the opposite reciprocal. So if the slope of the original line was -2/3, this will be +3/2. And so it's y minus 3 is equal to m, which is 3/2, times x minus 0, or just x. And so this one actually turns out to be pretty easy. It's just 3/2 x plus 3. So if you have any questions, please feel free to email me, try and contact me. Hopefully you found this useful, and hopefully I didn't make any major or glaring mistakes, but if I did, you can also please correct me on those. So have a great day.